Hi, Greg. Thanks for joining us today. Uh,
Hello,
Greg,
no problems.
Greg will open this VPS with his keynote presentation on pipelines to reuse or not to reuse. Greg is currently working with the Net Zero Technology Center and has over 30 years experience in onshore and offshore pipelines with roles ranging from design engineer to operations manager and project director, working mainly in the UK, but with periods in Australia and East Africa. During his time, Greg has worked with consultancies, construction companies, and major oil and gas operators. We will not have a Q&A session for the keynote speech, but I'm happy that Greg will also be part of the panel discussion right afterwards, where he's available to answer your questions later on. So thank you very much again, Greg, for joining us today. And please, the floor is yours.
Okay. Well, good afternoon to everybody, or I suppose it's good morning to some people. Just moving on with my presentation. So in this presentation, I'm fairly quickly going to cover the sort of the background to some work that was done last year and this year on basically looking at repurposing pipelines. I'll go through and I'll end up covering the results of a test case that we undertook. And I apologize, I realize I missed it when I was updating these slide packs. There won't be time for questions, okay? So background. Yeah, there's thousands of kilometers of existing pipelines. We all know there are major developments in CCS and hydrogen that are planned. We also know that some of those pipelines that exist will be suitable. There's going to be a lot that won't be suitable for one reason or another, but there will be ones that are suitable. All that existing infrastructure represents a very major economic benefit, obviously. But how do we ensure that the work that's needed to actually check and assess whether these pipelines are suitable is focused in the right areas? Now, the key point I want to say here is that what I'm going to talk about is not a replacement or an alternative to existing codes and standards. It's something that supplements them and helps ensure that you actually focus in the areas that are important in regards to that particular pipeline. This grew out of work done nearly 15 years ago now, which looked at pipeline life extension, but not from the point of view of, can we get another 5 years, another 6 years? The question was asked simply, for how much longer can we safely operate this pipeline if we don't change anything that we're doing? Simple question. Turned out it wasn't that straightforward to answer when you were talking about a pipeline. It was actually a pipeline system of several hundred kilometers, and it consisted of pipelines of varying ages and varying sizes. What we ended up doing was using a FMECA approach, and it worked on the pipeline, on that life extension. It really did work, and it revealed things that nobody was expecting. So this seemed like a good approach to build on that in terms of if we're going to repurpose, because let's be honest, the majority of repurposing also involves a life extension. Couple of points. Yeah, it's easy to focus on why a pipeline can't be repurposed. That's not what we're trying to do with this methodology. You got to realize that new technologies or new applications of existing technology are likely to be required. And also, it may not, although I talked about life extension, it may not be a major life extension. When we talk about repurposing, it is a perfectly valid business model to plan to replace all or specific sections after a defined period of time. So it's not unreasonable, if the economics stack up, obviously, to say, right, we're going to start putting carbon dioxide down this line, but actually within 5 years, we plan to replace A, B, C, and D. That's not an unreasonable approach. The methodology, as I said, it's FMECA. The advantages, you develop the links between the cause, the effect, and the criticality of the actions that are to prevent or mitigate whatever you're concerned about. You actually reduce costs by identifying and allowing focus on the areas that are really of concern. It can be used at a screening level, and in the test case, that's what we did, or in real detail. Disadvantages, the actual FMECA itself can take longer and therefore cost more than originally estimated. Care needs to be taken when you start looking at software aspects, your control systems and that, and the human interaction implications. Those are issues when you get into the detailed work rather than the screening level. You also need to take care about the team you pull together. You need to make sure they're not prone to overly optimistic assessments and are really focused on not what they believe or what they understand, but in making sure that what they work from is what they know. If it's we understand or we believe, then that should be a trigger for an action to be generated. So what are the major steps? All right, you've got the FMECA, but that's at the core, but there's work either side of that. So what we're talking about here is the first thing you need to do is actually understand what are the limits and the scope that you're talking about. You need, as I mentioned before, you need to be careful about it in agreeing the team. You need the right mix of experts. You need the right mix of people who are familiar with the operation. And don't underestimate the advantage of having an experienced control room operator involved. But you also have to ensure that you've got the right people who haven't got a long history, because they're more likely to ask the awkward question. You're going to need, and this isn't the team for the FMECA. What you tend to have in doing this is you have like a core team that do all the background work. Then you have the FMECA team. So the core team really needs to start by reviewing all the documentation. And it's surprising how often that turns up issues right at the start. You need to look at your PIMs. You need to review your safety-related equipment. You need to double-check the laws and regulations that apply to you. Sometimes in changing the fluid, you may find yourself into a completely different area in terms of legal requirements. There's no point in just saying it's the pipeline. You need to look at it. You need to segment it correctly and look at it section by section. You then go into assessing the current condition, which is the feed into the current condition FMECA. Coming out of that, you do your final review. At that point, you can start looking forward, because you now got a good base as to where you are. And remember that coming out of the current condition FMECA and review, you may have actions you need to undertake before you really can look forward with confidence. You need to understand your service limits for the look forward. You can then move into the look forward FMECA. It could be that coming out of that FMECA, you will then need to do some modeling. That's fine. And then all of that feeds into your final decision making. But like I said, you can do it at the screening level or the very detailed level. If you do it at the screening level, you can then use that as the start of a well-documented process taking you through the detail. Anyway, test case. Screening only. 3 workshops. 1 for current status, 1 for changing to CO2 transport, 1 for changing to H2 transport. The pipeline operator hasn't given me permission to give their name or say which pipeline, but they were involved with somebody who had worked on the pipeline for about 20 years, I believe. Crondall Engineering, DNV, and Apollo Engineering all contributed people for the workshops. Basic pipeline information: 36-inch, over 20 years old, dry gas throughout its entire history. We had an annual pipeline integrity report, and we had a recent inline inspection report. We divided it into 4 sections. So we had an onshore section, a nearshore section, the main section, and then the spool and riser. When we went through the current status, great news, no immediate threats were identified. But what we identified was that there was in the information provided, we had nothing on the susceptibility of the pipeline to cracking. That was probably a more detailed review would probably have revealed that. There was nothing, although there was lots on the pipeline or the line pipe, for want of a better term, there was nothing on the status and condition of valve internals. And obviously over 20 years old, you would expect that something is probably starting to degrade. There was confusion in the temperature limits. There was some indications that the lower temperature limit may have been changed at some point. There was no information about the frost heave potential for the onshore section. And there are pipelines in similar conditions, similar situations that are known to suffer from frost heave. There was no information on the fatigue loading on the different sections to date. And there was a lack of information on the condition of the external surface of the pipe in the splash zone. Again, a lot of those probably would have been addressed during a detailed review. We then went into the CO2 side of things, and we identified 3 key unknowns. Because there's a lack of information on the valve internals, we could not identify what the impact of CO2 would be on those components. We had insufficient information on the isolation joint, so again, couldn't assess the impact of CO2. There were obviously doubts, would a current -10 minimum operating temperature be sufficient? Now, you need to look at how you're actually going to operate the pipeline to understand that. When we moved to hydrogen, again, key unknowns: impact of hydrogen on the valve elastomers, impact of hydrogen on the isolation joint, again, the -10. There were some concerns about the impact of the external coatings on H2 migrating through the pipe wall. Valve performance and implications when you talk about hydrogen. Also, impact of bolt strength on bolt strength of small hydrogen leaks at flanges. The final assessment was, the test case demonstrated overall approach had merit. It was successful in identifying areas for further investigation that may not have been identified without this approach. And as I said earlier, further advantage, it can be expanded as more details available and provide a robust audit trail on the investigations and assessments of each aspect and issue, which is obviously important from the point of view of giving everybody confidence. So that's really all I was going to say. We have a methodology that is a useful guide to helping ensure all aspects are covered. We believe it's a positive way forward. Potentially can be adapted for other infrastructure, obviously. And it is actually available, the methodology itself is actually available on the Net Zero Technology Centre's website. And that's it for the moment.
Yeah, thank you very much, Greg, for giving us an insight into future perspectives for the huge amount of UK offshore pipeline assets. And I'm happy that you will be with us for the panel discussion right afterwards, and that you are with us to answer questions that may have arisen from the audience. So thanks again, Greg. And I would now like to move on with our panel discussion.